We discussed the WUMP drawings today and created some understandings about similar figures, and you're practicing that on your homework tonight. Problem number 4 says Zach wants to find the height of the flagpole at school. One morning he determines the flagpole cast a shadow of 12 feet, which I've not shown very well here. I've obscured it with this picture unintentionally. Let me draw that dimension back in there, and I'll explain why I put the picture where I did. This is the shadow of the flagpole, 12-foot shadow. If Zach is 5 feet tall and casts a shadow of 3 feet, what is the height of the flagpole? So, because the sun, that's a great sun, because the sun is creating the same angle with everything, you know, the sun's rays are coming down at the same angle depending on the time of day. This angle for the flagpole is congruent to this angle that casts the shadow for Zach. So these angles are congruent. We know that the flagpole is at a right angle to the ground, and so is Zach standing at a right angle to the ground. So if those two angles are congruent, then these angles must also be congruent for a triangle. And so we have similar triangles. Once you realize you have similar triangles, then it's like the other problems. You just have to compare corresponding sides and set up a proportion. I moved the picture over inside here to show you that if Zach's shadow was just touching the end of the flagpole shadow, then you could see these similar triangles would be nested inside one another, and you can sort of see that the triangle created by the flagpole and its shadow is just an enlarged version of the triangle created by Zach's height and his shadow. And so it sort of helps you see that they're similar. So if you compare corresponding sides, like if I compare the shadow length, this shadow length to this shadow length, and then this height to this height. In fact, you could make a ratio table: shadow, length, which is given in feet, to height, which is also given in feet. If you fill in this ratio table, then you can set up your proportion and you should be able to solve for the height of the flagpole. Why don't you try doing that during the pause and come back and see how you did.
Paused.
Zach's shadow length is 3 feet and his height is 5 feet. The flagpole shadow length is 12 feet and the height is what we're trying to find, x. There's a nice convenient scale factor of 4 here, which you can apply to the height to determine that x equals 20. If you didn't see that, you would do a proportion 3 over 12 equals 5 over x, and then write your cross product equation. 3x is equal to 12 multiplied by 5. So 3x equals 60. Then you would divide both sides of the equation by 3 to reveal 1x or x. It also gives you 20, so 20 feet would be the height of the flagpole. I hope that helped with the homework. I'll see you tomorrow.